Good evening, Dr. Latha Madam.
Sir, good evening, sir.
Good evening, Madam.
Good evening, sir.
Thanks for joining.
Thank you, sir. Thank you.
In another 5 minutes, let us start, Madam. Some students are joining now.
Okay, sir.
Wait for 5 minutes.
Okay, sir.
Anthony. Anthony. Latha Madam.
Sir.
ಶುರು ಮಾಡೋಣ.
Sir.
Good evening. We have resource expert Dr. Latha MS. She is currently working as professor at SVCE College, Bangalore. Madam, on behalf of Karnataka Science and Technology Academy and all the participants, hearty welcome to you for this
Thank you, sir.
webinar. Forward to your talk. And also I welcome all the participants who have joined for this very interesting webinar. Before beginning the talk, let me briefly introduce Madam's achievements. She's, as I told, she's working in SVC Engineering College. She is the professor and LIC member at BTU. She is also R&D coordinator, NAC and NBA coordinator in the Department of Civil Engineering at Sri Venkateswara College of Engineering. She has more than 19 years of experience in both teaching and research, and she holds a Bachelor's of Engineering, ME in Structural Engineering from Bangalore University, and she completed her doctoral degree from the very prestigious Indian Institute of Science, Bangalore. Her area of interest include sustainable materials, composites, masonry behavior, earthquake analysis, microanalysis, study of concrete, etc. She has published more than 30 research papers in national and international journals of repute. And also, she has presented papers in conferences of national and international uh, level. And she is also a reviewer of many journals in the most prior prestigious Journal of Materials in Civil Engineering, Springer publication. She has reviewed, and she has also published reference books titled as Sustainable Material Construction, Design of Masonry Structure. Dr. Latha has also filed and published a patent and received grant from Government of India. She is a life member of ISTE, ICI, IEI, and member of IEEE. Madam has received a prestigious awards for her achievements. She received Research Publication Award from our own Vision Group on Science and Technology, chaired by Bharat Ratna Professor CNR Rao, and also received a grant of 20 lakhs from Vision Group uh, project on most probably K-Fish, I believe. And she also has received international bilateral program Indo-Uzbek grant of 15 lakhs from Department of Science and Technology, Government of India. And she's also a recipient of prestigious awards, including Bharat Shiksha Ratna Award, September 2021. And she is also a recipient of the prestigious Dr. APJ Abdul Kalam Lifetime Achievement National Award, again 2021. Madam has received this Lifetime Achievement Award, I believe, very quite early in her career. It is really a noteworthy one. We wish Madam to get many more awards and accolades like this. Madam will be delivering a talk on sustainable construction, alternate construction materials. Madam, many students have joined on Cisco WebEx and many more will be joining on YouTube. On behalf of KSTA and all the participants, I once again welcome to you and over to you for your talk. Thank you.
Oh, thank you so much. Thank you so much for your very good introduction, sir. So I thank Karnataka Science and Technology Academy, Bangalore, for inviting me as a speaker for the Science and Research program. And now I really take up the privilege to present sustainable construction, alternate construction materials. Students, I think I'm audible to you. You're
Yes,
clear
madam,
with
yes,
my
madam,
talk?
you're audible. Please continue. You're audible.
Yes, yes. Sustainable construction, at first, sustainable, which emits low carbon dioxide will be emitted to the environment. That is the first criteria to be kept in mind. And we are looking at the alternate construction materials. What is the alternate or alternative to the construction material? We'll be looking the significance of the webinar. What I'm presenting here is with respect to the reducing the carbon emission to the environment. Now, coming to the abstract, there is a association called as LEED and IGBC. You can see IGBC and LEED, which says that leadership in energy and environment Design or Indian Building Council. These two important association which look for the eco-friendly materials. Eco-friendly material. So going with this IGBC and LEED, we have different alternative materials. I myself has worked with the students to come up with alternative building materials. Okay. My presentation is divided into 3 parts. Okay, as called as part 1. Right. So part 1 is with respect to Madake or a bamboo. A Madake called as bamboo. Why this bamboo? Where is this bamboo has come from? It's a plant which will absorb carbon dioxide, emits lot of oxygen, lot of. But it is not only the property of bamboo. It can be used as a construction material. As a construction material. As a construction, it can be used. So going with this, we have experimented for college institution, right? So or the overview of the presentation talking about all the parameters which is talking about the influencing the parameters of bamboo usage in the construction purpose. How we can substitute the construction material using bamboo. Now, as you know, that concrete and steel is playing a major role because with concrete and steel it is not possible to go for any type of construction. I think in interrupt, sir, there is an echo formation. Am I correct? Sir, there is an echo formation.
Madam, please tell me.
Echo formation. There's an echo formation. There's an echo. Echo is 1 second. Okay, sir. Now I'm audible. I'm audible, students. Hello, sir. ಇವಾಗ ಸರಿ ಹೋಯ್ತು. full screen ಹೋಗ್ತೀವಿ sir. Okay. Now coming to the topic of introduction, I was talking about concrete and steel, how the concrete and steel plays a vital role for the carbon emission. The concrete consists of a cement, right? Cement, aggregates, and sand. And aggregates and sand. In the cement is a major culprit to emit carbon to the environment. And even the steel, the production of steel takes place. During the process, you find. Hello, sir. Oh, the sir. Okay. Okay. during the process of steel production, during the steel production, you find amount of temperature and environmental warm or heating temperature will be emitted to the environment, and which is causing a high impact to the global environment. Okay, though we know that steel is a high tensile strength when compared to concrete, we have to use it. But today in this generation, students, do we have a substitute for a concrete and steel? Even though I know and everyone knows this concrete is emitting lot of carbon, but even though the steel is emitting, but do we have any such substitute? Yes, of course we have. Of course we have, as called as Madake. We call it as a Madake or a bamboo. Bamboo is a high versatile amount of material which could be used in place of a reinforcement. Okay, coming further, now we can see this chart, which is composing of transportation and building operations, building materials and construction and industry. What is the amount of heat or the carbon emission is being given out? Okay, if we see here, the transportation of materials or anything, it can be 23%, industry is emitting 32%, then building materials and construction is emitting 11%, then building operation is going with the 28%. Totally we can see it as more than how much? You can see more than 70% of carbon is being emitted. So to overcome this, we have to overcome by different materials. It's the year of 2022, students. We have to think for the different material to be utilized. Now we can see a picture, an image being taken up, telling that the carbon emission is being taken up with the building or the building construction, isn't it? We can see here lot of amount of carbon, or the smoke itself is a carbon, right? So this is creating a global warming effect completely, and this is destroying our earth. So we have to think about how to overcome that. It is there within us how to replace such a material, right? But not completely, but definitely we can replace it by a partial amount of replacement is possible. Now we are talking about the cement, right? You can see this is a cement. You have a physical view also. This is the cement bags, and you find the cement plant. This is a plant where the manufacture of cement take place. So these cements have been tons of tons. It has been manufactured. At the same time, there is a tons of carbon being emitted to the environment. One bag or 1 kg of cement, if I'm manufacturing, it will equally produce that amount of carbon to the environment. This is a fact what we are talking about. Even now we can see this is a reinforcement. You can see reinforcement. When I split this reinforcement, that means I'm providing a support to the cement. I cannot all alone use what is cement for the construction. I should be reinforcing with the bars. These are the bars. What you can see, this is a reinforcement. Lot of cement bars are being used. How is this manufactured? Is that readily available in the market? We pay and we get it, students. It is not possible. That we have to look into the manufacture of it. It is very, very important. So to understand the manufacture of cement, manufacture of reinforcement, how much of carbon being emitted, we have to understand here. Now this is a process telling about the cement production. Cement can be produced in the process two ways, as a dry process. Whatever it is, a dry or wet process, I'm not worried. But see the complete picture, students. You can see there is a lot of contents being involved. Like you have a quarry dust, you have a crushing plant, then you have a raw material. Everything takes place. Every setup has to be made. Every equipment facility has to be made, and manpower is required. Lot of amount of energy is required here to produce the cement. Okay, similarly you can see the cement which has been manufactured in the wet process condition. What is the setup overall it is required? So it is not an easy thing. It's an easy job. Just I carry one bag of cement from the shop. The production of it is also very, very important to know. right? And the steel, the reinforcement. Now you can be constructing at home, your own house. You'll be using the reinforcement. See, the reinforcement bars are not available as it is. Raw material of cement will not be the final form. You have to get it in the final form. This is a raw material of the steel. We have to fabricate, we have to mold it in the definite form. So it's not easy for the steel to bend because of its high strength. So we have to bend, heat it, right, to the molten condition. To the molten condition, it will be more than 2000 degrees. It will be more than, then only it is possible to bend the steel, right? Similarly, you can see the operation in the industry of the steel production, where you can see the person is standing here and working and associating the job to function or for the manufacture of steel. So what we understood from this, finally, what we understood, the cement production and the steel production is involving lot of lot of energy it is involving. How to overcome? Yes, there is a natural material called as Madake or a bamboo. I'm not telling that Madake will or the bamboo will take up completely. No, no, no. It's not possible like that. We have to partially replace it wherever it is possible, right? So for that, you can see this is a picture of a bamboo, a raw bamboo plant. I said to you earlier also, the properties of bamboo is highly friendly and very generic to our human beings. So we can utilize it to the maximum because of its very good nature, that it can absorb carbon dioxide and emits lot of oxygen. You can see in our institute also we have bamboo plants being in the campus. Once the bamboo is dried on its by its own life, when it is over, the life of the bamboo is over, this is a dried bamboo what we get. The strength of bamboo is very good, students. For that we have tested. Bamboo we cannot use as it is to the construction, right? We have to test it, right? So this is a source what I have taken from one of the literature available. So the bamboo which was in the dry condition, which will be taken into a cut piece of the required height, and it will be tested in the UTM machine, that is universal testing machine. After universal testing machine, the strength, the tensile strength will be estimated, which will be put up across a stress strain graph. So that is showing that very good strength it has achieved. It has achieved a very good strength. Similarly, when I say a bamboo, you will have a mind that it is a wood material. Yes, definitely it's a wood material. So for which we have to take the strips, we have cut the bamboo to strips and soaked it in water, right? Just by soaking as it is the bamboo in water, I could find the water absorption to be 51.2%, which is very, very high to be used for the construction purpose, right? So, but what I did, we have used the tar and the sand to cover the absorption, to treat the bamboo, right? Once it is being coated with the coal tar, we found the reduction of water absorption to be 16%. This is a reference what we took it from the literature survey, right? So number of IS codes, Indian standard codes are available with us. Specifically IS 9096 and IS 8242 will indicate the best features of the bamboo and suitably telling about the methods of test to be conducted. Right now, this is the image of a scanning electron microscope, right? Scanning electron microscope. As I said, bamboo cannot be utilized directly. We have to test it. One of the tests was testing in the universal testing machine, right? After once it gives a good reading, then we further go for a scanning electron microscope. It's a test, one of the tests. We observe the layers of the bamboo. This is the layers of the bamboo. This is also the source is from the literature survey taken, and it is understood that it is showing some layers, but these layers are along with the starch. You say ganji, it is along with the starch. This starch is what it is doing. It is playing an important role, making the bamboo to go soft. Okay, this is the highly magnified image of the bamboo. When it is being taken as an image, you can see how haphazardly it is being arranged. So over this coating, you can see the cellulose, the starch. You can see the cellulose being attached. This is a natural untreated bamboo. Once I treat the bamboo with the coal tar, what happens? The coal tar is having some temperature within that. This coal tar will make the cellulose to have a dissolved. It will get dissolved. So you find a good layer being formed. Further, you can see that this is a two image where it is been not treated, and you can definitely see the difference. The Madake fiber or the bamboo itself, when it is taken, you can see the starches have been inculcated in the holes. It is in the holes. So it is not having a good good strength to gain, because having a wet strength will definitely decrease the complete strength of the structure. So to overcome that, we started treating that. We started treating, and these are the observations what we made. Significantly modification after treatment, the starch material in the cell cavity, whatever the you have the cell cavity in this, the starch material got dissolved, and cell wall was intact. Intact money, it will be strong, right? So this is a study what we have made. So regarding bamboo, how we started collecting the bamboo, then we study the strength of the bamboo, then we have to refer to the codes. It is not that easy, students, as it is I use it some XYZ material and do it. No, no, no. We have to really investigate the material before using. Then we have to go for ACM scanning images. Then we have to treat these cellulose. So the treatment was coal tar. Then we proceeded with the application. You can see my student from MTech student. We are using this. He is treating the bamboo, the solid bamboo. We have taken the solid bamboo and started coating with the coal and stump. We started painting with the coal, then with the sand. Therefore, the surface becomes rough. Therefore, the surface becomes rough. So we made a collection of required number of bamboos, right? One species was available. Don't worry, any species can be possible to take up, but it is a trial and error basis. It goes with. Then we have designed for the beam, then started with the steel construction, then coating of Madake with the coal tar. Madake is nothing but bamboo, then sprinkling of sand took place. Then this is a final version of the treated Madake. So this is what you can see. Where was bamboo? Bamboo was long back. This was a bamboo what we could see. This bamboo has been changed into usable bamboo as a structural element by treating with a coal tar. By treating, then we prepared the cage. For the beam. We are preparing the cage for the beam. So you can see the solid bamboos are being used in place of reinforcement. And after this, we also have a comparative study with the ordinary conventional reinforcement. So you have the two different types of reinforcement. One is with the bamboo and one is with the steel. So that my study has to conclude while making a comparison. Any study, students, you take any study, you have to have a comparison with the conventional type. So this is a conventional. And finally, we have to prepare the cages like this and start pouring the concrete. The beams were cast. Finally, the beams were cast and they were cured, and after 28 days, it was asked to test. The beams has to be tested. So this is a loading frame what we do it. It is not simply I say that bamboo can be used. We have to show that how it can be used, right? So this is a beam which we have casted. Similarly, what we have shown here, using this bamboo steel stirrups, and with using the steel stirrups, we have cast the beams. We have cast the beams both with bamboo and with only steel. Then after that, the process doesn't stop. We have to test and tell the people, right, what the bamboo is doing is. So this is a loading frame. This is a loading frame, students, which will take the maximum load, for testing. We can test using this loading frame. We can test beams, we can test slabs, we can test columns, right? So using this, we started testing. You can see the arrangement made. You can see the student is making the arrangement. It has to be centrally placed, symmetrically and centrally pasted. Remember, students, this beam is composing only of bamboos as a steel reinforcement, not with the conventional type, right? Now, the load is being applied. You can see the failure is completely happened. Very nicely it has failed. Very nicely, exact type of failure as the steel will fail. You can see here the bamboo still it is here as intact. Bamboo has not failed. Bamboo is still intact. Still it is intact. So it can take up the load even more. Intact money, it can take up the load even more. Right? Now, we have to proceed further. This is with respect to bamboo. With respect to bamboo cage. Correct? Bamboo cage. Now we have to proceed with the steel cage. Steel cage. Right? Two types of studies we continued. Steel cage. So a beam was cast using only the steel cage. Again, it was applied for loading using loading frame. Then the failure pattern you can observe. It was all similar. Both bamboo and bamboo, this is for bamboo and this is for steel. Both had an equal type of failure. Equal type of failure. Then there was a plot of graph taken place. Plot of graph was taken place and analysis was performed and the equation was taken up telling that the maximum deflection, because we saw the bending, it was bent, right? That means deflection was happening. The deflection was happening, right? So when the deflection was happening, so what is the amount, maximum amount of deflection? It is taking 11.2. So which is within the permissible codes, within the permissible codes. Similarly, we went for the deflection calculation for load and deflection for steel. Even there we found the deflection to be to 8.2. So a lot of analysis was performed between two types and data was collected and we tabulated, we calculated the variance, we calculated the combination and all that. We could drop the graph like this, right? Varying the percentage of bamboo with the percentage of steel, how much it was varying. So there was different variation, different loads it was taking different loads. So hence with this experiment, we can conclude that Madake or the bamboo is recommended to use as a reinforcement in concrete and 30 to 50% of steel is possible to replace. If I'm able to replace 30 to 50% students, it is very good, isn't it? 30 to 50% money, I'll be using only 70% of steel, remaining 30% I can use for the bamboo. So this is a versatile procedure we can use for the construction. We have to step ahead to take up the decision for the use of bamboo in construction. Correct? So this is an application. It's a sustainable materials. Bamboo is a sustainable material, right, which is very much locally available and can be used directly for the construction after some brief treatment required. Okay, students. Okay, now coming to the next part of the presentation, which consists of bale and a soil. What is bale? Bale is a hay, hullu. Bale is nothing but hullu, hay, hullu. Then soil, both are naturally available. Both are naturally available. Correctness, students. Both are sustainable materials. Why it is sustainable? It will emit low carbon, less carbon, low carbon. It will emit less carbon because I don't require any type of manufacturing process to prepare bale and soil. It is naturally available. I can use as it is. Correct? So now we conducted one more experiment in the campus with our students and we introduced the manufacture process of stabilized soil bale unit, right? And you can see here students are working. We introduced a capsule, bale capsule. We can see the students are working, taking the capsule bale, using the bale. The bale is being bought from the freely brought. It was freely bought from the agriculturist for the farmer. He was just giving away because he doesn't want that. But the tensile strength of this bale is very good, students. So we thought of why don't we use this material in the construction, right? So all of us started preparing the capsule, bale capsule. Okay, so you can see this is the raw. We are just twining it and putting it in the form of a bale capsule, right? And finally it was cut and the design was made and such that it should weigh only 0.11 or 0.15. That is a maximum limit of the bale to be used in the blocks, right? For the blocks. Because why I'm using bale? It is to improve the strength, And so this is the final output of the bale. These bales are ready to use in the construction or the manufacture of blocks. This is a final bale capsule. So once it has been made ready, we started with the mold. We have a mold of size 400 by 200 by 200. Here, very neatly, we took up the composition, students. Here also, a soil is being used, soil, correct? And minimum percentage of cement. I don't require 100% of cement. I require minimum percentage of cement. And you can see this is a quarry dust, which can be used as a sand, right? All three are being taken. You can see the capsules also. All three are being taken along with the capsule. But make an observation, students, here. We are using very much minimum amount of cement, right? Very much, but I'm using the available soil. The available soil is easily available on the earth, and quarry dust is available. Even the byproduct of the quarry dust also, I can convert into a quarry dust and use it. Okay, so all the three were mixed and form a slurry. Why? Because it should have a flowable type of mix. So you can see how rigorously we are mixing it. We are mixing here also, right? So the design gave a composition of 1:1:6 with a water cement ratio of 1. So you can see the cement slurry was prepared. So we can see in the mold we poured the mix, right? By layers, we have to make the measurement. So placing slurry with a depth of 30. So the mold is of 200 mm height. So we place the slurry at first for a depth of 30 mm. Then after that we placed two capsules were placed, right? The Bale landers are placed in 2 layers, capsules or Bale landers, whatever we can designate. Okay, and after that the mold was completed with the remaining 2 more capsules, one above the other, and this is a complete finish. So after finishing, after demolding, after 24 hours, we can see the block is out. This is a block. You can see I didn't use much of any cement, and I don't require any time also. I need not wait for any equipments. I need not wait for any manpower. I don't want any machines. I will be using with the existing materials, that is called as sustainable materials. And the carbon emission is very low because the cement percentage what we are using is very, very less when compared to other type of construction. And whereas we are using a soil and bale, which is plentifully available on this earth, right? So this is the final block what we have seen. So I usually after whenever we use cement, students, we have to cure it for 28 days. How to cure it? Again, I want a water to cure it. So what I did, this bale or a whatever hay you call it as, this bale has a provision of pores, right? Within that it has provision. It can capture lot amount of water. So what we did, we made a bed of the bales, and we placed the blocks, right? And cover it. Started sprinkling. Therefore, I'm reducing the amount of water content. And I need not once in a day if I sprinkle, that is more than enough. Otherwise, you have to keep it in a water, correct? If it is a concrete made up of, right? It is not at all a concrete. I'm not at all using aggregates, right? We have to keep it in water. Then I require a manpower. All that been reduced here, right? So this is a sprinkling process taking place, which is being covered by the bale. Then after this, we have to test it, and this is right now we have patent this. We have kept for evaluation under the patent for the process. It is completely sustainable material. It can be very good, very nicely. It can be utilized. It is having a good strength, and it can be utilized for a temporary structure or a major structure. I don't agree that you have to construct a whole building with a concrete. You go for a part of it, 10% of it with these materials, 20% of these materials. See the originality, see the environment, right? When I use soil and bale, something like this as a natural occurring material to use in the construction, see the environment. Yes, to understand this environmental aspect using this type of construction, we are undergone one more type of work as a project in the campus itself. So which is called as stabilized soil bricks. In the stabilized soil bricks, as by name it goes, soil. What type of soil I should use? I should use a soil which is red in color or black in color, any color. You can use any type of soil. But before using, we have to test it, right? There are a number of tests to be performed for the soil, right? We have to sieve it, sieve it, then test it for hydrometer analysis. All that. Once the engineer approves this soil is ready to use, we carry on further to proceed. Okay, and you can see this is how it is being tested. This was a raw sand, raw soil as it is. It was available at some place. We got it from that and we transported here, and we have yard here. We have loaded, right? Then after loading, we have to use a sieve. This is called a sieve. One person here, we can see the person is being employed here, who is not being educated. He is working very well and happily. Employment is increasing, therefore. So he is sieving the sand. Sieving the soil. This soil has to be utilized. So before it has to be utilized, you have to perform a test. This is a laboratory test which has been performed. That is called as hydrometer analysis. Hydrometer analysis has to be performed, and wherein the soil is being passed through the particular sieve, and certain amount of soil will be retained. And once the soil is being again tested, right, passing through 4.75 sieve, it will be tested for the further test to get the approval for the conduction or the proceed for the construction of the brick. Okay, now you can see here soil, sand and cement are being used. So this is the soil, right? Once the soil is being sieved, you can get the soil which is passing to 4.75 mm. This soil will be used, and once the soil along with sand, we can mix, and very minimal quantity of cement will be used. Very minimal quantity of cement will be used. Therefore, what I'm trying to do is I'm just overcoming the usage of cement. I'm using the soil, not the cement. In earlier we saw, today also we see, you just walk around in the roads, you find every building is constructed with a concrete, correct? Every building is emitting carbon. Students, construction is completed. Yes, it's completed. What the other part of building construction, throughout its life, it is emitting carbon. Throughout its life, it is emitting carbon. So the global warming is going high and high every day. So we have to look how to reduce it. So that is what I mentioned. Not the complete house to be constructed. Only a part of it house can be constructed with such materials, as I was mentioning about these blocks and the bamboo and all that, right? So we'll go further with the stabilized soil bricks, right? So these are the bricks, and this is a mixture. You can see there is a team member, one of our team member, he is rigorously mixing the mixing the quantity of soil. Soil is a major portion. Soil, sand and cement. He is rigorously mixing. So we should get an homogeneous mix. Once it is mixed, depend upon the design requirement, we can see the design requirement. You can add water. The required amount of water has to be calculated. With the design. Then the water will be added. Then once the water is added, students, we should see to that it is being mixed uniformly, accurately, right? Accurately and uniformly it has to be mixed. Now we are talking about the stabilized bricks, right? To get the stabilized bricks, we own a machine. By the VGST approval project, we got this machine, right? We had purchased this machine, which is a brick making machine. It is generally called as brick making machine. The wet mix which has been mixed here, the wet mix will be taken in a quantity depending upon the design. The quantity will be taken. You can see the team member is filling up this brick, and using his liver arm, the person will press down so that the compaction takes place. Compaction means strength takes place. So after pressing, you find a beautiful bricks coming out. Beautiful bricks made up of only soil. See how beautiful the color is. It's a very pretty color of soil. Where you can see the cement. The carbon emission is very, very low. Very, very low. See here, I'm not using any machines, any workplace. I'm just nominating or employing 3 laborers. They are getting the position, they are doing the work, no machines or equipments are required, no transportation of materials required, nothing. Very simple mechanism of producing stabilized soil bricks. You can see number of such bricks have been manufactured. This you can see, that is a stacked brick. After 24 hours, then after curing, you can see these are all the stacked bricks. These are all the stacked bricks. They are placed. Number of bricks are being manufactured in the campus for the same purpose. Right? Once I said that it is after manufacturing, it is not possible to use as it is. We have to ensure that the results, the compressor result, whatever the tensile result, water content results, all that should be within the permissible limits of IS code. Okay. So this is a compression testing machine. You can see here, which is being, the load is being applied, and the load is very good when compared to burnt brick. Right? Burnt brick will give 7 MPa. 7 MPa as a strength. Even this brick is this stabilized soil blocks. Stabilized soil blocks is giving a strength of 10 MPa, which is very good when compared to the ordinary bricks. And lot of construction has taken place. So when I test it, you can just, if I open the layer, first layer, you can see what is this? It's complete soil. The soil is as it is. As it is. It is not being eaten away by the cement. It is as it is. It is available in nature. I can reuse this material. I need not throw away in the dustbins. I need not demolish it. I can reuse, recycle. I can crush once again and reuse for the manufacture of the block. Correct? So very good property of stabilized soil blocks. Now, after this, we found that after this material block construction, our students, we all planned, we started with a project to study the environmental aspects. Talking about the construction and the room temperature, outside temperature, that is ambient temperature, we have to look for, right? So what we did, we started constructing two model houses. One model house was constructed by stabilized soil blocks, and the other was constructed with a burnt brick. Okay, burnt brick. So two model house were constructed. So we were studying with the comparison, how it will behave, the environment. Okay. So now you can see this is a complete model of the stabilized soil block, and this is a burnt brick. Okay. Now what we started measuring the temperature within the room, within the small room, model room, which is the model room. The observation was carried out for 3 months. For more than 3 months. Okay. We want to study the temperature. As I said, that complete house need not to be constructed with such a stabilized or sustainable materials. We can also go for a portion of it. How it behaves, we have to understand. So we studied with the environmental aspects. So when we started with recording the temperature on daily basis, we recorded the temperature on the daily basis. Every day we were recording at different intervals. Per day it was not recorded just like that. It was recorded every day at different intervals. So number of recordings were found here. Number of recordings. This is a plot telling the temperature in degrees Celsius, and this is the time, right? Now you can see here SSB is a stabilized soil brick. This is for SSB, that is stabilized soil brick, which is made up of soil, and you can see here this is the ambient temperature. Ambient temperature means surrounding temperatures. This is a surrounding temperature outside the house, surrounding temperature. And this is a burnt brick temperature, right? Burnt brick, right? So this is what you can see. I use the thermometer or the setup required to measure the temperature both in the model rooms of stabilized soil blocks and burnt brick. Okay. Then we measured the temperature and we plotted how nicely it behaved. Very nicely it behaved. We can see for a long run, students, it was the stabilized soil block was showing a less or a very low temperature, very low temperature when compared to burnt brick and when compared to ambient temperature or the surrounding temperature. Don't you think this is a very good advantage? Yes. I have a cooling effect within the house with the construction of such type of bricks, isn't it? Now we can see this type of bricks are being utilized, can be utilized for the construction. not by a whole, but by a part. Similarly, what I said about the Bale blocks, the Bale blocks, what we discussed here, the Bale blocks having a very good insulation property. This is having a very good insulation property. Even the temperature effect has been introduced here, and it can be very well used for poultries, because we are using the bale which will give us a good temperature within the room. So one is a temperature insulator, one is a temperature maintaining very low when compared to the bricks or the ambient temperature. So such comparison has been made and been creating an awareness, telling that yes, Baba, you can use stabilized soil blocks, and it is having a very good strength when compared to burnt bricks or with the solid concrete blocks, right? Because in the manufacture of solid concrete blocks, students, you find the complete sediment is required. So you can think of rooms being constructed with the stabilized soil blocks and a concrete blocks. You can see the difference. The concrete blocks is emitting throughout the day, it will be emitting. Therefore, you'll be using your fans. Therefore, you'll be using your AC. Am I correct? So, or the cooler you'll be using to reduce the temperature. In case of stabilized soil blocks, what do? You need not. That itself will keep the temperature low. That is what we can understand from this graph, right? And we should all say that. We should all say what? Say yes to the sustainable materials in construction. In construction. Yes. You have any doubt, any query? Let us discuss now. Let us discuss.
Thank you very much for a very scholarly and informative talk on alternative materials.
Yes, sir. Thank you, sir.
Most of us are not from engineering background.
Sir.
I understood what you told. Lot of
Sir.
messages for all of us. I'm
Yes.
sure students will be interested to pursue their research
Yes.
they take up in future on sustainable materials.
True, sir. True.
Madam,
They can always come forward and work on these type of materials, come out with a very good results, which will really help the nation. We have to reduce the carbon production to the environment. That is a motto of today's generation.
carbon
Yes, sir.
footprint we have to reduce by using sustainable construction material.
Yes, sir.
There are one or two questions.
Yes, sir.
Madam, uh, compared to the burnt brick, stabilized brick, what you told, is it does it have same strength or even better?
Even better, sir. It is having even better, sir. It is having even better. Stabilized soil bricks as having even better. Because how it is better, I can say you the strength. For example, I can say the weight of one stabilized soil block will be 9 kg, for example, but brick will not be having that weight. Therefore, the strength increases because I'm using purely soil. So the weight increases, eventually the strength also will increase. Therefore, but in case of burnt brick, what happens, sir? Complete, you find a porosity is induced. When porosity is induced in the burnt brick, what happens? Definitely the strength will reduce. Yes, sir.
Madam, when you use bamboo along with iron, so
Yes, sir.
yeah, so quantity of cement that you use for construction reduce if you use bamboo or will it be the same?
Sir, in the case of bamboo, we have to look for the replacement of steel
Correct.
reinforcement.
You are right. Steel reinforcement, correct. Any idea about quantity of cement if only iron is used and if iron and bamboo are used?
Sir, there is always a possibility to reduce the cement by replacing the small portion of cement by soil. A suitable soil has to be included. Not that like 100% of 100% of cement I should not use. I should replace it by 20 or 30% of soil. That is maximum allowed. Yes, sir.
Earlier, our ancestral houses used to be made of bamboo and soil only.
Yes, sir. Yes, sir.
After 300 or 400 years.
Yes, sir. Yes, sir. The cycle repeats. But today, bamboo is a versatile material, sir. We are not having that awareness. We can readily use it. Only we have to treat it and use it. That's what I'm telling to every public. Not that whole construction or the beam construction need not to be replaced by 100%. Only one part, one beam or two beams, three beams, which takes less load. If the owner of construction is worried about the strength, he can definitely go with the replacement with one beam or two beams, sir. Not all.
And one more thing, temperature difference between the building constructed only with iron and the building constructed in part using the bamboo. Is there any difference, madam?
Temperature, sir. Temperature, if I'm using with cement, bamboo with cement, there's no variation, sir. If I'm using the beam construction along with bamboo, soil and cement, the temperature will reduce. How it will reduce, I'll tell you, sir. The soil has an intact clay content. The clay content can imbibe or absorb some amount of moisture. This moisture will be available, but it will not damage the structure. This moisture will give you a very cooling presence in the building. So therefore, only using bamboo and cement, the temperature will not reduce, sir, but I can assure the replacement of reinforcement. If I'm looking for the scope of temperature reduction, then I have to replace cement with some amount of salt. That is possible. Therefore, the temperature reduction may happen, sir.
Madam, one more thing. This bamboo replacement, can it be used in any climate and any area, or is there any restriction?
No, sir, there's no restriction.
Like in Malad and Pur, you get lot of rains. So
Am I audible now, sir?
yes, madam, audible now.
Sir. So I was talking, if I'm taking 20 mm dia bar, if I'm taking a 20 mm dia bar, okay. Now, if I'm taking 20 mm dia bar, in place of 20 mm, I can take 10 mm dia bar. Right, sir?
Yes, madam. Hello, madam, audible. Please continue.
Bamboo.
Hello. Yes, madam.
Hollow bamboo. I'll be using hollow bamboo.
Okay.
So therefore, I can reduce the amount of steel to be reduced.
Yes, madam. Madam,
Yes.
but there may be one problem. Is
Yes, sir.
bamboo cutting is allowed? Hello.
Sir, bamboo cutting.
is allowed by forest department, or there are some restrictions?
No, no, sir. In market, it is available, sir. At
Also.
market, you find the dealers available with a bamboo supply.
I was under the impression that there is restriction for bamboo cutting in forest area.
Yes, sir. You are correct, sir. But we are not going to forest area, sir. We are meeting the dealers, those who sell this bamboos. We purchase from them.
So,
There are different diameter of bamboos available, sir. Hollow bamboo, solid bamboos. For varying diameters, it is available.
thanks, madam. It is a new subject. That's why I myself asked you questions.
Okay, sir. Most welcome, sir. Most welcome.
Are there any questions, Anthony? Anthony? As of now, there are no questions from students. Since
Okay,
there
sir.
are few students, they are a bit shy. They might send questions to email later. If they send, we'll forwarding it to you. Kindly answer
Okay,
them.
Okay,
Yeah.
sir.
On behalf of KSTA and all those who are present in this webinar, I'm immensely thankful to you for this very scholastic talk. And madam, we'll be organizing many talks by experts like you in
Yes,
KSTA.
sir.
We'll be waiting for future talks also, madam. Thank you very much.
Yes, sir. Definitely, sir. Thank you, sir. Thank you. Thank you, sir. Thank you, sir. Sir, now I can leave?